The first one we're going to look at is one about the spreading of rumors. And I think this one, like especially with social media, would be like a really good problem. It's not talking about social media in this one. I think this textbook was written probably before social media is such a big thing. But like news spreads super fast on social media, right? Especially like on Twitter or something. Even like fake news, right? Someone can post something that's not true, and then that spreads to thousands of people, over a short period of time. Spreads exponentially because one person sees that post and then they post about it, and then a bunch of people see their post, and then so it just kind of has this exponential growth, right? So here we have spreading of rumors, and the model here, N represents the number of people in a college community who have heard a certain rumor, and so it's spreading exponentially. P is the total population of the community, and D is the number of days that have elapsed since the rumor began. Some rumors spreading around the college campus. This is a community of 1,000 students, so 1,000 students, and we want to know how many days before 450 of them will have heard the rumor. So like about half of them. So how many days will it take till about half the campus has heard this rumor, or whatever this rumor is? All right, so I would definitely on all of these when you're solving them, make sure you write out the equation. As always a good first step. Write out your equation. All right, figure out then what we're trying to find. What's the variable we're asked to find here? Right, D, because the number of days, asked how many days, so we're going to be solving for D, which means every other variable needs to be replaced. E is not a variable though, E will stay E, E is a constant, so we need to replace N and P. So we have two other numbers, 1,000 and 450. Which one's N and which one's P? Yeah, P is 1,000, right? The population. So 1,000 is P. That's how many total people there are. And then so N's got to be this 450, right? We want to know when the number is equal to 450. Good. And then everything else will just stay as is. That. And we're going to solve for D. Now we just have one unknown variable, it's D. So what's our first step? Get the D. Yeah, we'll divide by 1,000 first. Get rid of that 1,000 over there. Okay. Go ahead and do that with calculators. 50 divided by 1,000. I'm going to do that over 2 times. You get 0.45 equals 1 minus e to the negative 0.15 d. Basically, we're just trying to get the e by itself first, and then we'll get to that d. But we got to get rid of this 1, right? So we'll subtract 1. Don't add 1, it's subtracting 1. Because there's an invisible plus sign in front of this one. We'll subtract 1. So we get negative 0.55. The e still has a negative with it as well. Right? Both negative. So what do we do now? How do we get rid of that negative? Yep, go to negative 1. Both sides. It essentially just cancels out the negatives. Right here. So then we got 0.55 equals positive e to the negative 0.15 d. All right, now that we got e all by itself, we can do the natural log. Both sides. Also, just make sure whenever you plug a number into a natural log, it always has to be positive. You can't put a negative into a natural log, you'll get an error. So you should never end up with a negative. Just a reminder that you need to divide by the negative there. So we got the natural log of 0.55 equals these cancel, negative 0.15d. And although that has a negative with it, it's still multiplication. So So now we divide by negative 0.15. Get d. And then so we're going to type this whole thing into our calculator. Natural log of 0.55 divided by negative 0.15. Generally, you'll get you might get a decimal, but you can round up to the nearest whole number for something like this. Should be like 3.98, so approximately 4 days. 4 days, about half of the school up there, the river in 4 days. So all of these have the similar idea of like solving for whatever the variable is using natural logs. Just making sure you get them plugged in the right spot. And I want to just do one more here. I can't remember if did we do this one in this class or just talk about it? We just talked about this one. Okay. Well, let's go ahead and solve this one. Talked about so this is like an oil change place. What's that? Where you drive in and you change your oil for you while you're sitting in there. All right, so you're going to do one very similar to this with probability. Just a couple minutes, so make that about this and solve it. All right, so it says between 5 p.m. and 6 p.m., cars arrive at Jiffy Lube at the rate of 9 cars per hour, which is about 0.15 cars per minute. Following formula from statistics can be used to determine the probability that a car will arrive within t minutes after 5 p.m. Here's our formula. This tells us the probability that a car is going to arrive within a certain number of minutes after 5 p.m. So our first question is to determine how many minutes. So that first part will tell us what we're trying to solve for, right? Determine how many minutes. So that means we're going to be solving for t, right? Are needed for the probability to reach 50%. It's maybe a little bit confusing what you do with this 50%. This 50%, there's only one other place it could be plugged into, right? Where does that have to go into? Yeah, it has to be here, right? Because this is the time. Well, obviously doesn't go there. That's the only other variable. Just be careful here. This f of t, a couple people were doing this first period. They were writing whatever this was there, but they were keeping a t. So like for part A, we're going to write the percentage always as a decimal. So it's going to be 0.5. But it's not 0.5t. Okay? This f of t just says it's f, but there's t's in the function. Okay? So it's not 0.5t. That would be incorrect. It's 0.5. That's our f of t. That's our probability. I guess the f stands for like frequency or something like that. So f of t is 0.5. And then we're going to be solving for time because it asks how many minutes. So then it's just a very similar setup. 0.5 equals 1 minus e to the negative 0.15t. And then we just got to do our inverse operations to solve for it. So what do we do first? Move the 1 over, right? Subtract 1. Yep. And after you get the hang of this, they're all pretty easy. They're all relatively the same. Here. All right, then we divide by negative 1. Go to the negative. We get 0.5 equals e to the negative 0.15t. And then we take the natural log, right? Cancels natural log of 0.5 equals negative 0.15t. And then we divide by negative 0.15. And that's going to be our Plug it in. Alright, so you should get 4.62 minutes. So what does this mean? It's saying there's a 50% chance that a car is going to come in within the first 4.5 minutes. So if you got to get something done, like maybe you got to run to the bathroom real quick before a car comes, yeah, 50% chance they're going to come in their first 4 minutes. All right. So I think probably hopefully have a good enough understanding, I think, to do some of these now. Yesterday and today. Okay. So your assignment is going to be 4 problems. They do have some of them have multiple parts, but you're going to have about 30 minutes to work on it. So ask me questions. You can work with someone if you want to as well. Ask for help, and